Sterile manufacturing. Utilities. Content. Purpose. Utility control. High-risk utilities. Utility management. Monitoring and trending. Records. Installations consideration. Closing remarks. Purpose. Ensure that utility systems are designed, installed, qualified, operated, maintained, and monitored to function as expected, minimizing risk to product quality. Utility controls. Risk assessment. Controls should match the risk to product quality. Document impact assessment in the Contamination Control Strategy, CCS. Higher risk utilities. Direct contact. Utilities that directly contact the product, such as water for washing and rinsing, gases, and steam for sterilization. Contact materials. Utilities that contact materials that will ultimately become part of the product. Contact surfaces. Utilities that contact surfaces which come into contact with the product. Direct impact. Utilities that otherwise directly impact the product. These utilities should be designed, installed, qualified, operated, maintained, and monitored with heightened control measures due to their potential impact on product quality. Utility management. Key aspects. 1. Design. Utilities must be designed to meet the specific requirements of sterile manufacturing. Ensure that the design incorporates contamination control measures. 2. Installation. Install utilities in a way that minimizes contamination risks. Ensure that installation allows for easy cleaning and maintenance. Installation should follow current standards and best practices. 3. Qualification. Perform qualification to verify that the utility system operates within specified limits. Includes installation qualification, IQ, operational Q, and performance qualification, PQ. 4. Operation. Operate utilities according to established procedures to ensure consistent performance. Regularly review and update operating procedures as needed. 5. Maintenance. Develop and implement a maintenance schedule. Perform preventive maintenance to avoid unexpected failures. Document all maintenance activities. 6. Monitoring. Monitor critical parameters and quality attributes regularly. Utilize trend analysis to detect and address potential issues before they impact product quality. Monitoring and trend analysis. Critical parameters. Regular trend analysis for high-risk utilities is essential to ensure system capabilities remain appropriate. Monitor parameters such as temperature, pressure, flow rate, and microbial contamination levels. Trend analysis helps in identifying deviations from normal operation and allows for proactive measures to be taken. Records. Objective. Maintain utility system records throughout its life cycle. Records to maintain. Current drawings and schematic diagrams. Construction material lists and system specifications. Detailed records of pipeline flow direction, slopes, diameter, length, tank and vessel details, valves, filters, drains, sampling, and user points. Maintaining comprehensive records ensures traceability and aids in troubleshooting and maintenance activities. Installation considerations. Cleanroom installation. Pipes, ducts, and other utilities should not be present in cleanrooms. If unavoidable, they should be installed in a manner that prevents recesses, unsealed openings, and surfaces difficult to clean. Ensure that utilities do not compromise the cleanroom's integrity. Design installations to allow for easy cleaning and disinfection of outer surfaces. Proper installation is crucial to maintaining the cleanliness and sterility of the manufacturing environment. Closing remarks. Maintaining proper utility system controls is essential for ensuring the safety and efficacy of sterile products. Regular monitoring, appropriate scheduling, and adherence to defined procedures help mitigate risks and maintain high standards of cleanliness and control in sterile manufacturing environments. Thanks for watching our channel. Feel free to reach us at contact@learngmp.com.